Hello everyone. We are learning cases of Doppler effect. So yesterday we was in the concept that moving target, isn't it right? So let's see this topic. These are the cases of Doppler effect. Keep it in mind. So in this case, we are going to learn when target is moving, then what is the effect of that on frequency? Moving target. Okay. This is the concept that is moving target. Now, let us suppose there is an observer and one target, we can say, that is a wall. This is a wall. And let's assume that this target is moving. Okay, because in the concept only we have mentioned that target is moving. So let us suppose this is moving with velocity v. It is what? Target velocity with which that wall is rotating. Got it? Yes. Now, this finished about this wall and its velocity. Now, assume karo there is a source like this which emits sound. So this is the source and its velocity is zero. It is not moving. Source is not moving. So there it is. Source. And assume that here is observer and observer is also not moving. That's why source velocity also we have considered as a zero and observer velocity also zero. But this target is moving. What will happen then? The waves from this point, yes, they will come like this and they will get reflected and reach to the observer. Yes or not? Like this and then like this. Now, either this target can move this side or else this side also. Yes or no? Isn't it? So, let's assume in first case that target is moving towards the observer this side. Okay, this wall can be moved here or here. So this is I am taking as a case number 1 and this one I am taking as a case number 2. Case 1 what? Towards the observer. So let's see case 1. Target moving towards observer. Yes or no? How? That wall is moving towards the observer. Then what will be the effect of this? So first of all, due to this wall, whatever the apparent frequency is there, n dash is equal to p plus pt by v into n naught. Why this is coming like this? Here, this is the first frequency, that is the actual frequency we can say, So I am denoting there the frequency of this is what? N naught. Where here? Which is emitting. Now it is coming and reflecting, and in this case it is moving source. For this observer it is a moving source. So you can get that condition. Yes, observe that ray source is coming towards, then you are getting this one. Yes or no? That is target is moving here in this case. So what you are getting? P plus PT, not PS here. P plus PT, because this is moving, not this. So now for observer, this is for wall. Whatever this frequency is there, this is for wall. Now for observer, what you are getting frequency? N double dash is equal to N double dash is equal to P plus Pt divided by P minus Pt into N naught. Okay. So target is moving towards observer, then you are getting frequency N dash is equal to V plus Pt by V into N naught. And when, or for observer, which is here, for this observer, your frequency is what? P plus Pt by P minus Pt into N. In case of case number 2, in case of case number 2, that is when this target is moving away, when this target is moving away, then what is the formula? Target moving away from observer. If target is moving away from observer, what you are getting? N triple dash is equal to, here you will get minus, here you will get plus. P minus Pt by P plus Pt. Why? Because just you have to replace this Pt in this above formula with minus Pt, isn't it, right? Yes or not? So can I write like this in bracket? Replace Pt with minus Pt in the above formula. Where formula? In this formula. Yes or not? For this case, that's why we are getting this formula. What is that? P minus Pt by V plus P. Why we have replaced this with minus? Because it is in opposite direction. So this frequency for wall is N dash is equal to V plus Pt by V into N naught, and for observer P plus Pt, P minus Pt into N naught. Okay. So next, note down this. Yes. Next, transverse Doppler effect. What is the next note point? Transverse Doppler effect. How this is what, if the source is moving by making an angle theta with observer. So what is this transfer Doppler effect? If source is moving, if source is moving in a direction making an angle theta with respect to observer. How? Let's see this. For this, let's draw the diagram. So how is this? In this case, source is moving by making some angle with the observer. So let's see. Assume that this is the source and it is moving along this line. Okay. And now observer is somewhere here. So your observer is here at point O. And this source is moving in this direction with velocity Vs. What is happening here now? You can see the source is moving along the line which I have drawn, that is dotted line. Along that line, source is moving. Where is observer? At point O. Then let's take some point. Okay. So now this line which it is joining to the observer, this line, and I am selecting some points. Okay. Try to draw straight lines. Now assume karo ki this is a point C. This point is point C. This point is point B. So source may come here also. So this is point B and this one is point A. Clear? So this angle here, it is 90 degree. Okay. And now if we will further elongate this line as well as this line also, and assume that this angle is theta, then if I will resolve this, then I am getting this as a Ps cos of theta, this component along the observer line. So as this is theta, this also theta, and then let's see what you are getting frequency for different points which we have denoted in the diagram. So what will happen when source is changing its position? Source, where it is their source positions. What are the source positions? Try to understand. Source positions A comma C comma B, isn't it right? Source positions are this. Next, where is observer? Observer at rest, and that is at point O. Okay, at point O. So let's see here cases and apparent frequency heard. So in this case, apparent frequency heard by observer. Number one, source at point A. When source is at point A, then here you are getting frequency, apparent frequency heard by observer. N dash is equal to NV divided by P minus PS cos of theta. Next one, second point, when source is at point C, when source is at point C, so I am writing only at point C, you can write full, you can write when source is at point C. Here theta is what? 90 degree. So this part will become 0 and hence you are getting here N dash is equal to N. Then third case, again third case you can see here it is opposite direction. So at the point B, at point B, what you are getting N dash here, just in this formula what you have to do, instead of this minus you have to give plus, NV by P plus PS cos of, clear? So see, when these type of cases are there, that is source is moving by making some angle theta with the observer, then how the frequency changes, that is which heard by this observer. When it is at point A, then N dash is equal to NV by P minus PS cos of theta. At point C it is perpendicular, so there is angle 90 degree and that's why PS cos 90 will become 0 and PV will get cancelled and hence you are getting N dash is equal to N. That is at that point there is same frequency whatever emitted by the source. Next at point B, you see now source is going away, yes, and then there you have to replace this PS with minus PS cos of theta and therefore you are getting plus PS cos of theta. Okay, so this is what? The transverse Doppler effect. Pause the video, note down, draw the diagram and note down carefully. Okay, next. Now, rotating source or observer, then what will be the change in frequency? Let's see. The next case, that is rotating source or observer. Rotating source or observer. Out of these two, anyone is rotating. Let's see that cases. So, pehla wala, rotating observer. Rotating observer. And दूसरा वाला rotating source. Yes. Now here in this rotating observer, what I am doing, I am taking source at the center, okay, and around this observer is rotating like this. Yes. So this is a rotating observer, which is rotating like this, you can see. And this is continuously emitting frequency of N naught. Got it? At this point. In this case, rotating source, what is the case? Observer will be here and around this line source is rotating. Okay, what is happening? Source is rotating like something like, okay. So in this case, here n apparent is equal to n actual. That is n dash is equal to n, and in these cases you will not observe Doppler effect. What is that? No Doppler effect in this case when it is rotating, either rotating source or rotating observer. So there will be no change in phenomena, there no change in phenomena of change in frequency, and that's what there will be no Doppler effect. You cannot observe Doppler effect in these cases. So note down, draw the diagram, pause the video. And keep it in mind, observer is here in between. Observer is here. Observer is here. Let's see now next case. Now this rotating source observer, in that case only I am taking this third case. Source is rotating. Source is rotating and observer is out of the circle. And observer is out of circle. Isn't it? Now in previous cases, observer was inside the circle. Around that observer, this source was rotating. Here it is not like that. Here it is different case. How? Let's see. Let me draw the diagram first. So you see here, assume that observer is here. Okay. And now around this circle or whose radius is r, this source is rotating now. What is happening? This source is rotating like this, around this. Clear? And this one we will take like this case. So one time it will go away from this, one time it will come towards like that. Okay. And this velocity is what? Vs of this source. And this observer is at rest. So in this case, what will be the frequency heard? Maximum frequency heard. N max, and there will be two frequencies, isn't it? Right? Because one time it is coming towards, one time it is going away. Like that it will behave. So this is also Vs. So in this case, you are getting N maximum is what? Nv by P minus Vs. You know this when it is coming towards. Right? And another one, minimum frequency possible is what? Nv divided by P plus Vs when it is going away. If we will take ratio of these two, that is what? N max by N minimum is equal to what you are getting? P plus Ps divided by P minus, just ratio you take, this Nv and we will get cancelled, P plus Ps by P minus Ps. How you got this formula? Because see, this is the first case when source is coming towards means maximum frequency. When it is going away, then minimum frequency. That's why here V plus Vs. Already we have learned this formula. Yes? Okay. Next case. Now case is what? That is fourth I am taking here. Now this was observer at rest and source was moving or rotating, we can say. Now source is out of the circle and observer is rotating. Observer is rotating. Right. So this is the fourth case. Observer is rotating. Observer is rotating. And source is out of circle. Source is out of circle. Now you will ask one more question also. Sir, if observer is this side, then also you will get same formula. Don't worry. Wherever the observer is there out of the circle, you will get same formula. Don't bother about it. Clear? Okay. So observer is rotating and source is out of circle. Then how will be the diagram first? Let's draw it. So now you can see here, this is the source which is out of the circle, and assume that around this circle of radius r, this observer is rotating. Okay, and it is continuously emitting the frequency. And this one, you can take any direction, either clockwise or anti-clockwise. You can take one only above only, same pattern. So I'm taking like this. So this velocity is what? P naught. P naught is for observer, and this is the n frequency actual one. So in this case, it will treat as the observer is coming towards and observer is going away. But it will treat as a observer is coming towards and observer is going away. So in this case, n maximum will be what you are having, v plus v naught by v into n, and n minimum you will have, that is what, v minus v naught by v into n. अगर हम इसमें n max और n minimum का रेशो ले ले, so what you will get, n maximum divided by n minimum is equal to v plus v naught divided by v minus, isn't it right? So you got these formulas, n max and n minimum in this case, and here also n maximum and n minimum in this case. Here it is very simple. Just source is going away, source is coming towards, observer is going away, observer is coming towards. That frequency formulas only you have to use, none other than that. Pause the video, note down, draw the diagrams, write it carefully. Okay, if you have doubt, call. Got it? Note down. Okay, so next is what is the Doppler shift. Let's see what is the Doppler shift. That is next topic. Doppler shift. What is this Doppler shift? First of all, definition. See, it is difference between, it is difference between apparent frequency and actual frequency. Difference between apparent frequency and actual frequency due to Doppler effect. Clear? So what is this Doppler shift? Delta nu is equal to, you take magnitude of nu minus nu dash. Or you can write like this also, delta n is equal to magnitude of n minus n dash. That is apparent frequency. Hai na? This is mod I have taken. So either n dash minus n, the one who is bigger, you can subtract from that. Not an issue. So this is what your Doppler shift. Clear? Note down. Pause the video. Note down this. Yes. Yes. Now see. Next one, Doppler shift in radar. How it will be? Doppler shift in radar. What is this Doppler shift? You know it very well in radar phenomena. So radar is what? When microwaves are sent from the ground, when any obstacle is coming in the path, it will get reflected back, isn't it right? Suppose now, for example, suppose assume karo ki this is a microwave source, something like this, microwave source. So these waves are going, we are sending up, and suppose something that is like the plane or something, helicopter, whatever it is, but most probably, let us take this as a plane. You can see here, this is not fish, okay? So this is a plane. So when it will go and strike, it will reflect back. Clear? So this is what microwaves. Microwaves you have sent and reflected back. Then what will be the frequency of this microwave received by this plane and all these things? Let's see. So first of all, frequency received by plane, that is n dash, is equal to c plus v by c into n. Okay. V is what here? Speed of plane. What is V? Speed of plane. Speed of plane is V. V is what? Speed of plane. C is velocity of light. Now, or you can say c is what here, velocity of microwave also, not an issue. C is what, velocity of microwave. Clear? Now this is what frequency received by the plane. Now this plane is acting as a moving source. Now plane acts as moving source. Then the frequency of wave from it is, frequency of wave from it is n double dash is equal to c plus v by c minus v into n. And here if you want change in frequency, that is delta n is equal to n dash minus n. If we will do n dash minus or n double dash minus n, you are getting nearly equal to 2nv by c. Nearly equal. You can do it. Clear? So what is happening here? One more time, listen. This is a radar. I have tried one rough diagram. So some microwaves you are sending, they are getting reflected back from this obstacle. So first thing is that what frequency received by plane, n dash is equal to c plus v by c and n into n. Now plane acts as moving source, so frequency obtained from it is what? N double dash is equal to c plus v by c minus v into n, which is the reflected one. Understand? That is what another apparent frequency. And if you will find this delta n, you are getting 2nv minus by c. Pause the video, note down. And last one, uses of Doppler effect. What is that? Uses of Doppler effect. They are asking sometimes question on this. The first one, in sonar, you know sound navigation and ranging phenomena. Second one, in radar, they are asking for 1 mark. You can keep it in mind this. To determine speed of automobiles by traffic police. To determine speed of automobiles by traffic police. Next, to determine speed of rotation of sun. And tracking Earth satellite also. Tracking Earth satellite. Which applications we have already learned, that is rotating source and observer and all these things. By use of that, these are the applications of Doppler effect. So let's stop here. Watch the video. If you have any doubt, call me. Okay. So bye and enjoy the day.